am not wearing the same clothes as yesterday. No, this is like 2 seconds later. I just kept the video going. I have a second video here. This is STEM 2.8, and today we're going to write formulas where the positive has multiple charges. That's why we have this weird little table here, because it's showing different charges. Remember those? They were like different charges inside there. Yeah, so today we're going to do that, and we're going to look at that table real quick. I know I looked at it 2 videos ago. I did a big close-up on it and stuff, but we're going to peek at it real fast. So this is naming ionic compounds with multiple charges. Let's see what we have here. I'm flipping back through. Hey, there's the old ion chart, right? And look right there in the middle. Most of these are D blocks, right? But just look at them. They have more than one charge. I have a message on my thing right where I need to write. There we go. Look at that. Cobalt 2, cobalt 3, nickel 2, nickel 3. Remember, the only difference was the charge. And they told you which one it was by using a Roman numeral to be the same number as that charge. And that's all we're doing here today. Okay, so let's go back and let's look at these things and see if we can get this thing done. I'm trying to keep these videos as short as I can, so let's see what happens. Here's the notes. Oh, man. Oopsie. That was a work of art. Just destroyed in seconds. Okay, here we go. So we have FeS, right? Well, we're going to have to figure out what charge that is. Now, the way we do that, this is weird. You got to look at the negative first. So that S, I'm going to find S on my chart. And I look on the old chart. I was just there. S, right here. Right there. S is minus 2. Okay. Boop. So if S is minus 2, and I do have to change the size of this font because paper looks small today. So if this S is minus 2 right here, remember those charges have to equal 0. So what does that Fe have to be? It has to be plus 2, right? Because minus 2 plus 2 equals 0. And we want these to be neutral. It's not, that's what it is, yes. So Fe is plus 2. So that's going to be, from that chart, that's going to be iron 2. That's a Roman numeral 2. Iron 2. And that last thing, S, look on that chart, find S, it's right there under oxygen, sulfide. Okay, so aluminum sulfide. Okay, I know, this is the hardest part of this whole section. There's not going to be very many of them. Now what I'm going to do is I'm going to go right back with the same exact elements in a formula. Same elements. Look, the numbers are different though. Subscripts are different. We have a 2. Oops. Whoa. We have a 2 and a 3, right? So let's do what we just did. So we're going to go back. And we know S is minus 2 because we already looked that up, but I have it written right there beside it. Okay. Now do you see it? Remember the crisscross? Right? So we brought that 2 down, and that 3 had to be brought down too. So what that means is this must be plus 3, because it's 2 and 3, right? So we just did the reverse crisscross, right? I don't know if that's really a thing, but that's just what we just did. But let's look at the total charges. We have 3 negative 2s. 1, 2, 3. 3 negative 2s. Ignore the pencil. That's 6 fingers total, right? And we have 2 plus 3s. And that's 6 fingers, right? 6 minus 6 equals 0. Okay? So that has to be with a plus 3 charge. That's going to be iron 3 sulfide. Oh boy, sulfide. There it is. I knew it was inside there. Okay? Now, I know what you're thinking. Mr. Arnold, what happened to those twos down there? Why aren't there twos down? There were twos, but they were reduced, right? That's where they went. That's the trickiest part of this. Okay, that was the only, oh, there's two more. Okay, let's try it again. So this is tin and this is oxygen. And so oxygen's charge is -2. You're like, Mr. Arnold, you didn't even look at that chart. How do you know? I just know. All right. So if oxygen's -2, that tin has to be +2. It has to be, right? So that's going to be tin with a +2 charge. So it's tin2. Oxide. In typical Mr. Arnold fashion, this next one, same exact compounds, but it has a different formula. So we can't have the same answer, right? It's not going to be tin2 now. So oxygen is -2, and there's 2 of them. I know what you're saying to yourself. 2 negatives 2's equals -4. So tin must equal, I hope you're saying +4. Because if we look on this chart and we find tin, there are 2 choices, right? +4 or +2. And they're always going to match one of those 2 choices. So we said 4 just a second ago, didn't we? We should have, because that's what it is. This is +4. So it's going to be tin4. Tin4, good buddy. If you guys were from the 1970s, that would be hilarious. Okay. All right, that's the hard way. Now we have one more section. I'm talking too long. I'm at 7 minutes already. I'm trying to go fast, right? Okay. The next section, we have the opposite. So we have iron 3 nitrate. Iron, we just looked that up. Fe was +3, right? Iron 3, Fe +3. Fe +3. So this time we're going to write the formulas. We do it the same way we did before. Nitrate, by golly, that must be a polyatomic ion. So we look on our chart, and we're going to find nitrate on there. NO3. I know you're on there, nitrate. There you are, nitrate, NO3, with a -1 charge. If it's a polyatomic ion. Right? We put it in parentheses, we put the charge above it, just like that. Make sure it looks like that. Crisscross, 1 and a 3. That 1 was optional, but we're going to put there anyway. Same thing, look what I have. Matching, they're twins. This is Fe +2, and again, I use nitrate again because I'm trying to show you that the way we can tell these compounds apart is from that little Roman numeral. So that Roman numeral means it's +2 for Fe. And so when we do our crisscross, we end up with Fe1, NO3 outside the parentheses, a 2, right? So we have 2 different formulas because of these little Roman numerals, and it helps us keep them apart. And it's real simple to do, and that's why scientists have this method. Yep, I'll do it. Okay. Oh my gosh, I just switched colors. Let's see, it looks like they're still having cami problems. Hopefully we get through this. Okay, copper. Hey, it's just like old times, but you can't run away from me. The bell rang, but you're at home. So we have copper, and copper can be either +1 or +2. So this one up here is copper 1, that's Cu +1, right? And then it's with oxygen, oxide, and oxygen is -2. Crisscross, we're done. Copper 2, Cu with a +2, O with a -2, same things, right? But they're 2 and 2 if they're going to reduce to 1 and 1. And I'm going to stop right now so I can get done with under 10 minutes. And I hope you guys have a great day. Goodbye.